So I have to listen to each one at a time. I have to cancel the ones that I don't want to hear of the three strings. So I put a cloth strip in between each note to cancel out the strings I don't want to tune to start with. And I have different types of rubber wedge mutes to put in between the strings. And then I start with A above middle C, and I'll set the frequency with my tuning fork. I listen to the piano, and then this is adjustable, so I can actually adjust the pitch to match what the piano is to find out how flat or sharp the actual pitch of that note, the frequency of that string. So I listen to and compare. You can hear me change. That's the pitch changing. Flat, and then sharp, goes up. And if there's a beat, if it's not in tune with what my standard pitch is for A, which is 440, that's the string beating 440 times a second. So that little vibration is really fast. And if the piano string is beating 441 times in a second, and my tuning fork is beating 440 times, I'll hear a wave. I'll hear a beat that goes wow, wow. It's louder and softer 1 time per second. So that's out of tune. And so now I have to take my tuning hammer and I put it over the tuning pin, and I'll move the pin that has the wire wrapped around it. The wire goes down across the bridge and is connected at the other end. So I have to move the speaking part of the string to change the sound. If I tighten it, it goes sharp, higher in pitch. And if I loosen it, it goes down in pitch or flat. And so I can move that just a little bit, a little tweak back and forth. Just doesn't take much movement to change the sound or to change the pitch. And then I listen to it and I match it. And then I go from that note down an octave and keep going from that first note that I tuned. I tune all the rest of the notes from that A440, that first note. That's the foundation. And there's a pattern for tuning that is the standard tuning that all piano technicians do today. The standard pitch in the United States is A440. So all the music you hear on the radio, your band instruments, they're all set to that frequency, so that when we play with other instruments, we'll be in tune together. And I have to set the pitch on a piano to that standard, and then go through the rest of all the keys to put it at pitch in tune. So there's really two parts to tuning. That a piano can be a half step flat, where A sounds more like A flat, and be in tune with itself, but it wouldn't be in tune with other instruments. The standard pitch in Europe is actually a higher pitch. It's 442. So just like in the US, we use foot and yard to measure distance, they use meters and centimeters. So our standard, a yard is this long, and their yard is a meter, which is different. It's the same thing. Their pitch standard is 442, which doesn't sound much different. That was 442. This is 440. Sounds the same, but there is a difference. If I slide it up, you can hear the difference. That's all. Whoop, that's a different note. But so there is a little bit of a very slight difference. And 100 years ago, the standard was actually 435, which is quite a bit lower in pitch. I don't know if you can pick up that difference.
We're picking up some of it's a little hard
Yeah, a
to
little
tell
bit,
on
just the
Zoom, but
idea.
yeah, the idea. Yeah, definitely. That's
So,
fascinating.
um, so going through the process of tuning, um, it was, I mean, 100 years ago, there wasn't a standard way to tune a piano. And now today we tune what's called the equal temperament. And the temperament is compromising, it's tempering all the intervals. So an octave should be beatless, or an octave is, there's no waver, that wah, wah, wah. But thirds on a piano, if you, they're all out of tune. They have a beat, yet we've gotten used to hearing it that way, and it's acceptable. We've gotten comfortable listening to an out of tune third, and that's but we intentionally make it that way. And fourths and fifths also are slightly out of tune on purpose. They have a slow beat of like one, just a little bit less than 1 beat per second for a fifth, and a little bit faster beat for the fourths. But we have to do that in order to fit all the notes evenly in the octave. So the A to A octave that I start with, and then I go down to F and go up to F, that is my temperament octave where I start the foundation of the tuning. All those intervals, the thirds all beat the same, but slightly faster. All the fourths should beat about the same. They should all sound the same. And the fifths, same way, so that it's a consistent, even um, pattern that I go all the way up to the top note and then down into the bass. But in order to make it work, we have to compromise. We have to slightly make those intervals out of tune in order to get them to fit. So that if we play in the key of C, the tuning is the same as if we played in the key of G or the key of F or whatever key we're playing in, the tuning will be the same for all the different keys we can play in. And 100 years ago, that wasn't the case. They would
Right.
tune differently for different, the key of C, then you couldn't play in the key of F sharp because you'd have really dissonant growling intervals that were out, just not, didn't sound good to the ear. In fact, they called them wolf intervals because they growled.
Interesting. I've not heard that term before.
Yeah, wolf
That way we
interval.
can play in every key, and particularly important when students learn about what they can do with their piano skills. They can, of course, accompany and play with other instruments. So that allows us to play with any instrument too.
Yeah,
So
and
excellent.
it's a lot easier to tune the instrument to the piano. You
Right.
take your guitar and tune it to the piano because you can't tune the piano as easily.
Right, because that guitar has 6 strings, and you mentioned a piano has about 270 to
Right,
alter. The guitar has
right.
a lot less strings to fix.